My name is Kenny. I am a software engineer at Coda. Thank you for the intro. And I'm on the AI team, and my main focus is on analytics and AI evaluation for our AI product. Truth to be told, I joined the AI team in 2023, right when ChatGPT rocked the world. So yes, like maybe some of you guys, I did join the AI hype train when it blows up. And before that, I was a data infrastructure engineer at Coda, at Box in a startup called Simon Data, where I focus on all things data engineering and analytics specific. Today, I'm going to share our journey at Coda, where we grow our Gen AI evaluation framework from the ground up. To start, I'm going to do a quick survey. By a quick show of hands, how many of you have tried integrating Gen AI into your application? All right, so looks like most of you. And this shouldn't be a surprise to any of you guys. So we should all be pretty familiar with this. Unlike code, Gen AI are non-deterministic by nature, and models can also change outside of our control. So as a result, having a systematic way to understand how changes impact AI quality is essential to a Gen AI feature application. And with that, this is the agenda rundown for my talk. We're going to go through some background, the challenge that we face at Coda, our journey on how to address it, and a couple of the key lessons that we have learned along the way. And hopefully by the end of the talk, you would have a better understanding of the importance of evaluation and maybe some specific items as well that you can take as you integrate Gen AI into your application with confidence. So, background. What actually is Coda? Well, that is a great question. I don't know if most of you have used it, but I'm going to do a quick marketing pitch. So this is Coda. Coda is an all-in-one workspace that has flexibility of a document and the structure of a spreadsheet, as well as power of an application, and it also integrates with the intelligence of AI. Well, that was a mouthful, but a lot of words, but what our user says would be, you can actually build documents that are as powerful as application. For example, in my personal update tracker, I can actually pull data in from Jira or GitHub to understand what I did in the past week and have it all integrated as a part of my weekly updates. So I don't need to pull information from like Jira, GitHub, and copy and paste it everywhere. And in terms of the features that we have built that are powered by Gen AI, we have the following. So this is an AI assistant that helps you generate content right where you are in a doc. So as you can see in here, we're asking AI to write a blog post about AI. So pretty meta. And next, you can also use the same assistant if you're inside like a spreadsheet, like a table structure. So in this case, we have a table that contains a list of animals. Within Coda, you can actually leverage AI to do some basic classification. Let's say, can this animal fly? Or you can use also AI to generate some content based on some different value in the row. So in this case, we're going to write a short intro based on the animal name. And there you go. And last but not least, so now those are the two assistants that help you generate content. We also have a kind of like a RAG system where user can go into a doc and ask questions about the content that they have on the page. So in this case, I'm asking, hey, what are the animals that are mentioned on this page? There we go. Whoops. So those are some pretty basic examples. This is a pretty basic document. But imagine you have an engineering wiki or an HR policy doc. In the past, people may need to go to like a Slack channel or like email HR to answer some basic questions about kind of like the general policy. With kind of like RAG system like this, they no longer have to do that. All they have to go is to go to Coda AI, ask a question, and then they would get the answers that they need. And that's the quick demo. And I'll switch back to my presentation. Great. So we just look at the AI assistant that we have built in. So what's next? The challenge. This is back in March 2023. That was when the time when OpenAI just released their Turbo 3.5 model, which is both faster and cheaper. We got really excited and we wanted to use it instead of the old Da Vinci model. And here comes the interesting thing. When we were testing it, we realized that all the prompts that we have written in the past no longer works. The responses are much more conversational rather than instructionals. So imagine you're a Coda user. In the past, kind of like the examples that I just gave, you can just ask AI to write a blog post about AI and it would just generate the blog post for you. With the new model, basically what AI would say would be, sure, here is the blog post you're looking for, the content, and then at the end it would say, let me know what you think. Well, it works technically. The user experience is completely different. And as much as we would like to move to the new model to take advantage of the new pricing and the speed, the uncertainty around the AI output quality just kind of like make us pause and rethink. Since as model upgrades, the behavior can change outside of our control. While we know that there will be changes, the things that we have observed, as we already know today, it's pretty dramatic outside of our expectation. As a result, we recognize that we need to have a more systematic approach to evaluate how Gen AI behaves, which would give us confidence so that as model and prompt changes, we know the quality of AI output will continue to stay at a consistent level. Which brings us to the next section, our journey on how to solve this challenge. At a very, very high level, our journey is split into 4 phases. The first phase is, hopefully most of you guys are familiar with this interface. This is the OpenAI playground. This was in the beginning of 2023, where everyone is still trying to get a hang of like, hey, how do we integrate GPT into our application? This is before system prompt or chat conversation is a thing. And all we have is this Da Vinci model. Using AI Playground is a great way for us to experiment and iterate. It's very simple. It's very easy to get started. Even our non-engineers, kind of like our designers and PMs, they can also help with our prompt engineering effort. But while it is great for iteration speed, it doesn't really scale well beyond like 10 data points, since it requires a lot of manual copy and pasting for it to work to get the eval going. And moreover, it lacks the ability to grade like an AI output and keep tracks of like how it behaves over time. So because everything is done manually and by copy and pasting. And so we tried this for a little bit, and then we realized, hey, this is not working. And since Koda at that time already has integration with OpenAI, why don't we try that out? Which is our next phase. Using Koda to solve this problem. And as you can see in the screenshot here, this is Koda. This is our little plump playground that we created back last year. We have a table here that contains each of the benchmark that we have. That's a row. And then if you look at the 4th column, which is the red arrow, that's where we, behind the scene, what we do is we combine the system prompt that we have behind the scene together with the benchmark data, and we fetch the response back from AI. And then we have another column under the blue arrow that gives us a way to basically do manual evaluation. This approach eliminated a lot of the manual copy and pasting work that we did in the past. Moreover, with this, now we have a way to understand and compare performance between different prompts or different models. So it's pretty basic, but it eliminated some of the manual work for us. And so we got that going for a little bit. Unfortunately, when we start adding more and more features, we hit another issue. What happened was, this is back in March and April 2023. That was when OpenAI first introduced the conversational model, GPT 3.5 Turbo. And because of the way the structure is being changed, in the past it's just like, hey, a single, basically user prompt. Now you have conversations, you have system prompt, etc. The work that we need to maintain the document that we have to do AI Playground has increased by a lot. We were still pretty lean at that time. We only have less than 5 engineers. And instead of spending time maintaining the tool, which we spent a lot of time doing at that time, we would rather focusing on improving the AI quality instead of like maintaining tools. This is kind of like the classic build versus buy problem that we encountered, which with that led us to the first purchase of our AI vendor, Vellum. So we adopted Vellum to address our AI eval playground needs. In Vellum, you have the ability to define and share your dataset and your prompts with different people, so others can join the effort on evaluation, and prompt engineering. So as you can see in the screenshot, each column here contains a different prompt, like here. And then similar to Coda, each row is also a benchmark record. And when you click run all, what Vellum would do is to basically combine the prompt with the benchmark data that you have, get some answers from AI, and you can actually go in and manually rate it, similar to what you did in Coda. So green means, of course, it's a pass, and red means fail. So we really like Vellum because it gives us a quick way to prototype and iterate without the need to maintain a tool. And the interface that we use is still pretty similar to what we have with OpenAI, which is very friendly for a non-technical audience. So yeah, that's it. And however, as we increase the number of features that we support, we're hitting some limitation. Number one, our eval is actually decoupled from our application code. If you look at all the examples that we have, what we're evaluating is actually the prompt. But our application code not only takes the prompt, but they also do additional manipulation on top of it. As a result, sometimes what we run into is like, when we run eval, everything works great. But then when we run it actually in the application code, when we run it release it to the alpha users, the results that we get is dramatically different. And when we look at the payload, we observe that, oh, actually what we evaluate, the way we structure the prompt is actually in the playground, is actually very different from how our application code combined them together. So that's number one. Number two, second limitation. We want to start automating some of the work that we've been doing manually. So in case you don't remember, even in Vellum, we have to actually go in and do vibe checks by hand. This is consuming, as the number of feature grows, it's consuming a lot of our time. And we would love the ability to basically automate some of these checks. As a result, we started integrating an automated eval workflow as a part of our integration test suite, where we basically run an eval similar to how we run test. And at that time, what we do is when we run the test, we export the results to Snowflake, and we use Mode, which is a reporting tool that we use to visualize data in our data warehouse. That works for a little bit, but similar to kind of like all these solutions that we get, at the end, what we have is we started spending more time maintaining that SQL and that reporting capability. While it works, we would much rather spend time on improving AI quality rather than writing SQL, which is where we met BrainTrust. BrainTrust met us right when we need them. This is back in middle of 2023. We already have a way to run systematic evaluation against our code, and we basically need someone to come in and help us to visualize the result and help us to track and figure out, hey, how is AI health, what is the health trend going for the AI quality? BrainTrust give us a very good, robust API where once we complete an evaluation run, all we have to do is to push all the score, upload the score to BrainTrust, and they can visualize it for us. So as you can see in this screenshot, at the very top, you have the timeline where you can see, kind of like observe how the score goes. In case you don't know, 1 is like a good score, 0 is like a failure. So not everything is happy yet. But you can kind of see how the score trend and changes over time. And at the bottom, this is each evaluation run, where when you run a job, you can get an aggregated score at a high level to see how the job is doing. And if you click into it, you get a little bit more details about how each benchmark is performing. So this evaluation run is a feature that we have to extract action items from a piece of text. And let's see, this benchmark is failing because the benchmark that we fit in is a chat transcript between a customer and a customer support agent. And since this is an extract action item task, we ask AI to basically extract action items from this transcript. But there's a trick to this. This benchmark data actually contains 0 benchmark action items. So this is a way for us to measure and figure out like, hey, did AI actually return and say, hey, there's no action items, move on with your life, things like that. But so yeah, this is with BrainTrust, it gives us the ability to not only looking at things at a very high level, but it also gives us a very easy ability to dive into specific issues so we can identify issues and fix them accordingly without writing a single line of SQL. So yeah, this is kind of like where we are. And today, we're still actively using BrainTrust for our scaled evaluation effort because of this robust API, the amazing out-of-the-box reporting that we need, and the flexibilities to support a different type of scorings and evaluation criteria that we have. And having said that, the tool itself is very engineering-focused and friendly. So for users who may not be as familiar with manipulating JSON or YAML file, potentially Vellum would be a better solution. And these are the 4 phases of AI evaluation that we went through, from OpenAI Playground to a combination of Vellum and BrainTrust. And before transitioning to the key lessons, maybe we can sum up our journey so far with some stats. Back when we started, we don't really have any features supported in our AI evaluation framework. We have 1 engineer involved as a part of the effort. We have no automated checks, and we can only run about 25 evaluation jobs per week because it takes time to actually manually evaluate and rate every single output. And now, fast forward approximately a year, we now have about 15 and more features supported. We have 5 and more engineers involved in AI in some capacity, and it's way more now. We have more than 50 automated checks, so that the amount of manual work that we do right now is relatively much less compared to before. And in terms of like evaluation job runs, we're basically running more than 500 jobs per week, and they're all automated now. And that's our journey so far. Key lessons. What are the key lessons that I guess I knew before I started? This is a really hard question to answer because a year back, we don't actually have any vendors that are providing the service that we need. And today, I think Honeyhive is over there. A lot of vendors actually provide a lot of the capabilities. I was reflecting on this, and I think these are the 3 lessons that are still relevant today. The lessons are: keep evaluation as close to your code as possible. Human in the loop is essential, and the importance of a great benchmark dataset. First lesson, keeping eval close to your code. As I mentioned, when we started our evaluation, everything is done in a playground. As we iterate on a prompt, we need to copy and paste and to keep the prompt in sync with our code base. And as mentioned previously, that started basically diverging what we evaluate and what the users actually see. So some of our evals are no longer evaluating what actually our AI system is generating. While the prompt-based evaluation is still critical because it gives us a really, really quick way to iterate. We need a much more accurate way to evaluate closer to what our user sees. And by keeping eval as close to our application as possible, when eval runs, you can know that you have confidence that, hey, what we're evaluating is to some extent, as close as possible to what the user is seeing. And what does that actually mean practically? So for me, my background actually came from data. I'm extremely comfortable with Python, which is a lot of the existing machine learning libraries are written today. But if your application is actually written in Node, maybe you want to think about potentially moving or implementing your evaluation in Node instead. That's lesson 1. Lesson 2, human in the loop is essential. In the beginning, your evaluation will mostly be done by hand, manually. And as you scale and iterate, you would most likely start moving some of the manual work into automated checks. The automated checks can be, for example, did AI return the right answer? Did AI format the response according to what you have stated in the prompt itself? However, even as we start moving some of this manual work into automated checks, there are still value in having human in the loop as a part of the evaluation. Because as we update the prompt or when we change between different versions of models, you may see failures that you have never observed before. While the automated check helps greatly, human can be kind of like the final gatekeeper to ensure that all the edge cases are covered. An example that we had was, so in Coda, we have a couple of features where we specifically ask AI to return markdown. And then what we have is like, we are using the November version of the GPT-4 Turbo model to power some of those features. But as we try to upgrade it to the January version, what we have observed is AI, instead of responding to the user in markdown, they actually quote the entire response with a triple tick markdown in a code block. It's kind of bizarre, but like those are the things that in the beginning, when we were looking at all the previous model, we would have never expected the AI model to return. And because of that, we need to start adding different evals to kind of catch that edge case, rerun eval, and to fix our prompt to make sure that all the outputs are aligned. If we think about it differently, we can think of like eval as like kind of like a loop. Having human reviewing AI output can help you identify the edge cases they haven't thought of, and you can turn those observations into automated checks, which in turn, over time, it would strengthen and improve the quality of your evaluation framework. So it's kind of like a flywheel, even though it's not really a wheel. So yeah, and you may ask like, hey, I just got started. How do I know what automated checks or criteria should I add as a part of the evaluation? One of the tricks that we found pretty helpful is like, you can run the same prompt on 2 different models, ideally 2 different vendors. You look at the results, and you will see it's like, hey, I prefer output from like model A over model B because of XYZ. Those insights, those preferences are actually things that can help you and turn into automated checks. So that's a quick trick that has worked really well for us. And that's lesson 2. And finally, lesson 3. Your eval is only as good as your benchmark dataset. We can have as many automated checks as we want. We can have as many human in the loop as we need. But if our benchmark dataset doesn't have a good cover on the actual real-world use cases, it cannot help us to suss out issues for us. And yeah, so having a good dataset is very important. But what should you include in your benchmark dataset? Well, ideally, everything that your user face, but sometimes it's really hard to figure out when you first start it because it's like there might be a code start problem. What we usually do internally when we create a new feature is we first start with our PMs and designers, ask them like, hey, what are the hero use cases that you guys have that you want to support in the first run? Get them involved, ask them to also contribute to the benchmark data set. Once we got the initial use cases ironed out, we can leverage different, kind of like what the other speaker was mentioning earlier. You can kind of like use the first set of a benchmark as like seed, and you can use Gen AI to kind of multiply your benchmark over time so you have a much more rich data set. And as you release the feature to alpha users, beta users, talk to them, leverage feedback that you get, to understand like, hey, where are things working? Where are things not working? What are they using AI for? And finally, but not least, don't forget your customer-facing teammates. They actually have a much more first-hand experience with understanding what the use cases are from the customers. As a result, talk to them. They might actually have some really good insight on what you need to cover in your benchmark data. A final pro tip is your internal usage is also a great source to beef up your benchmark data. So at Coda, we actually collect our internal usage data for analysis purposes from our development and staging environment. And we use them to identify gaps in our benchmark data set, and we basically use that to iterate. And I guess the last thing is like, you do expect to spend a lot of time on curating your benchmark data set, which is one of our biggest pain point right now. It just sometimes it would take maybe a couple of hours, even a day, to really figure out like, hey, given this feature, what are the use cases that we want to support? What are the edge cases that we need to make sure that the prompt is actually working before we actually ship? And unfortunately, there's like no hard black and white rule on like how to do it. You just have to basically sit there and think through kind of like, how can we break this? But when we first started, we only have one feature with about 25 examples in a Coda data table. And now we have grown to more than 5,000 data points. And it is a pretty long-term investment. It takes time to build out a quality data set, but the investment is really worth it, and you can only see it over time. In case you guys have already started or thinking about integrating your Gen AI into your application, but you haven't really thought about eval yet, what kind of tools might potentially be useful for doing your first eval or building out your data set? Again, Gen AI landscape has changed a lot in the past year. And there are a lot more vendors these days that can provide these capabilities, like Honeyhive, and who will give a talk later today, in this afternoon. But today, for me, if I were to start again from zero, what I do is I'll take the prompts that I have that I'm already using in my application. I'll probably sign up for a BrainTrust account, just basically create a prompt program, plug it in, create some benchmark data that I know using this as row button, run it. This would basically establish kind of like a baseline for my base eval data set. And as I scale, I would start moving these prompt playground evaluation closer to my application, kind of like what I mentioned before. And all these data set that that we have defined in BrainTrust, you can actually use their API to pull it back and run it against your application. So all the work that you have here to build out your data set is actually not wasted. And cool. And yeah, that's it for kind of like the lesson 3. So start early, even if it's small. N equals 10 is a great start. And once you have established your baseline, you can iterate on your benchmark data set as you go. And a quick recap. So I quickly walk through kind of like the challenges that we face and the goal that we have to have a systematic way to evaluate Gen AI quality output. We walk through the journey that we went through, where we go from OpenAI Playground to now a more systematic approach to evaluate our AI quality, and the 3 key lessons that we learned along the way. Keep evaluation close to your code, the importance of human in the loop, and the importance of a good benchmark data set.